Actually going to start recording this now. Okay, 3 ways to write a ratio. Give me one. Ooh, Jugba. Fraction in form. So we could have it say, let's have it 2 to 3. How would I take 2/3 in fraction form and write it differently? Ernest. Colon. 2, that's the 2 dots. I love that you use the word colon. Thank you. And what else, Javon? Last one. Yeah, 2 and the word 2. 3. Okay. A ratio, though, is not something. Does anyone know what this blank is? This blank on your paper. A ratio is not what? Jahaz? Why'd you raise your hand? I appreciate the way that you wanted to volunteer. Nellie, did you know?
A ratio is not a fraction.
A fraction, yeah. Sometimes it looks like a fraction, but it's not a fraction. So I'm going to type in here fraction. Okay? In the space below, it says this. Sorry, let me read this statement here. A ratio is not a fraction, but it looks like one, and it kind of works like one. In the space below, explain the difference between the fraction 3/4 and the ratio 3 apples to 4 bananas, which can be written as 3/4. Your explanation must be at least 4 complete sentences and contain the word whole. So I'm going to give you guys a couple minutes to write this down in complete sentences in silence. Please begin now. So let me say that again. A ratio is a way to compare 2 or more things. Now, I was looking on some papers. Evelyn, would you read us the first part of your paper that talks about what fractions are?
The difference between 3/4 and 3 apples to 4 bananas, because a ratio is something that you have part of a whole.
A ratio is part of a whole, or not quite. She's really close. She's on the right track, but this is a big thing I want us to make sure we know the difference of. Oh, I see some hands. This is great. Nellie, what is actually part of a whole?
A fraction is part of a
Oh,
whole.
excellent. A fraction is part of a whole. So, as Kenneth said, ratios compare 2 or more things. Fractions show parts of a whole. So those are the 2 big ideas that you need to get in your head, the difference between ratios and fractions. Ratios compare, fractions are parts of a whole. If you don't have those written down, write those down right now. Okay, let's move on down below here, some guided practice. Okay, it says that there are 10 boys and 15 girls in a classroom. What I need you guys to do is write this with a colon and then use words, and simplify as well too. So do these in the guided practice. Please do number 1, A, B, C, and D. Right now, we'll turn and talk and share in just a minute here. Okay. So from this point, I need some answers here. Who can tell me A? What's the answer to A? Let's have Javon.
10 to 15.
Ooh, he's close. Oh, can you tell me what part B is then?
2 to 3.
2 to 3. So he started out with 10 to 15, and then he reduced it of 2 and in words to 3. Cool. Who can do C and D for me here? C and D. Let's have Hosea.
C is 15 over 10.
15 over 10.
And for D, I got 3 over 2.
Okay, so we're writing in words, so you're going to write 3, 2, 2 in this case. Cool. Flip your papers. Let's do these real quick. Let's do boys to total students. Jugba, tell us boys to total students.
10.
Yep. 10 to 25. And reduce that for me, Donovan.
2.
We want to do number 1, part F. What are they both divisible by, Rochelle?
5.
5. Donovan, use that. Both divisible by 5. You're going to have what? 2 to 5. Very good. Okay. Now we're going to increase it a little bit here with bigger numbers. We have 2,700 students and 90 professors at a college. Write and simplify these ratios. Do A and B. You have 15 seconds to do this. Go. Okay. So 2,700 to 90 students. Give me students. That one's pretty easy right here. Oops. Here we go. 2,700 to 90 professors. But I'm looking for someone to help me reduce this now. Who can reduce this for me? No. You have 1/3? Sorry, that's actually not correct. I'm going to undo that. I'm going to undo that writing. Oops. Undo. Undo. Oh my goodness. Okay. I messed that up. Just a moment here. So if we want to have 2,700 to 90, let's have someone else reduce it. I haven't heard from... Who haven't I heard from in a while? Let's have Tyler.
You have
3 to 1? Not quite. We have place value. If we're going to reduce, 9 goes into 27 3 times. That's correct. But we have 2 zeros with the 2,700 and 1 0 with the 90. Hosea? Yeah, it's 30 to 1. Or 30 to 1. So the ratio of professors to students... Oh, wait a minute. Professors to students, I thought order mattered. Jahaz, help us out here. Students to professors is 30 to 1, but what's professors to students? Hugo? Yeah, it's 1 to 30. So I want to make sure that you guys have that on your paper right now. Make sure it's 1 to 30. Order matters. Order matters when we do these ratios. Let's move on. We have a couple of things. We have apples, oranges, jeans, and shirts. And then we have a challenge one where you have 3 things being compared. Quarterbacks, wideouts, and linemen. Let's have you guys do these with your partner. Turn and talk for 2 minutes. Make sure you have number 3 done in about 2 minutes. Ready, set, go. Hold up.
Wait a minute.
All right, I'm going to call on a few students to help me out with this here. Who haven't been called on for a while. Let's have Hugo give me part A.
1 to 3.
Say that again.
1 to 3.
Oranges to apples is 1 to 3. Very good. Thank you so much for reducing. They're both divisible by 21. Part B is going to be Mark. Mark, what do you have for part B of total shirts to total articles of clothing? Sorry, say that nice and loud, please.
7 to 10.
7 to 10. How'd you get that?
I had 35, 70, 50.
Okay, so you had 35 shirts and then 50 total pieces of clothing, and then what'd you do?
Then divide them by 5.
And you divided by both by 5. Good. 35 divided by 5 is 7. 50 divided by 5 is 10. Perfect. And part C, let's have Elmer.
7 to 11 to 2.
7 to 11 to 2.
No. 3.
How'd you get that?
I simplified. I reduced it. Each of them by 3.
Oh, you reduced them all by 3. So 21 divided by 3 is 7. 33 divided by 3 is 11. And 6 divided by 3 is 2. Very good. Thank you for putting them in the proper order as well, too. Let's go over one of these independent practice problems here, and then I'm going to actually make an independent practice, okay? So let's do number 1 together as a class, and let me show you how this is done. When reading word problems, we just need to read them carefully, so we're going to read them a couple of times. Nice and loud and proud. Can I have Kaya, please? Is she here? No, she's not here. Can I? Tajane is not here either. Let's have Jahaz, loud and proud, please.
Bottle has 50 centimeters of string and cuts it into 2 pieces. One is length 40 centimeters. What is the ratio of the longer piece of string to the shorter piece? And it's simple.
Excellent. You know what? I love the way you wrote that with enthusiasm, and you also had good inflection there. Thank you so much, Jahaz, for reading that with good inflection. All right. So Carol has 50 centimeters of a string. She cuts it into how many pieces, Audrey? 2 pieces. How long is one of them, Brian? 40 centimeters. So how long is the rest of it? Who can tell me how long is the other pieces? Let's have Siani. 10. So we know that one is 40. Oops, let me write this down. 40, and the other one is going to be 10. Now, it says the ratio of the longer to the shorter piece. Is this longer to shorter, or do I need to switch it? Someone raise their hand and share. Yes?
It's longer to shorter.
It is longer to shorter. Is this their final answer?
No.
No? Can someone raise their hand and share? Yes, Rochelle, what's the final answer? You got this.
Oh,
What do they both reduce by?
10.
10, and so our final answer will be
4 to 1.
4 to 1. Excellent. And that's your final answer right there. So I'm going to have you guys do independent practice, and you can work with your seat partners, okay? And by the end of, say, let's see, in 10 minutes, you should be done with number 12 and onto that page after the pictures of the fruit, okay? You should definitely be done with number 12 in 10 minutes. Any questions? Okay, you may begin. You got 3 to 1. Thumbs up if you agree. Lots of thumbs up, that is correct. Number 3. Mark. 2 to 1. What was the ratio before you reduced? 18 to 9 was correct, reducing to 2 to 1. Very good. Number 4. Oh, sorry, I apologize. This one right here says, what is the ratio of blue to red? So, in fact, this should be 1 to 2. Oh, it's okay. Order is important, guys. Remember that. Order is important. Number 3. Sharon has 50 sweets, 30 are yellow, 15 are blue, and the rest are red. How many are red, Tyler? 5. Ernest, can you tell us what we need to write down then of yellow to red to blue to red? 6 to 3 to 1. Thumbs up if you agree. Cool, lots of agreement there. That is correct. Let's move on. I want to tell number 6. What you should have gotten was 1900 to 600. But that reduces to 19 to 6. Divide both by 100. Okay, you had to subtract 2500 minus 600. You get 19. So that's what's left versus what was poured out. Number 7, I have drawn a picture of a rectangle on the board. You can see here if the width is 30 feet and the length is 30 feet and the width is 4 times it, that means that our width should be 120. Then we have to actually add up our perimeter. So 120 plus 120 is 240, 30 plus 30 is 60, so our perimeter is 300. So it says, what's the ratio of length to perimeter? So what we needed to figure out is that if we're writing this down then, our length is 120, our perimeter is 300. We can reduce this to 12 to 30 immediately, but then we can keep reducing it by 6, and we get 2 to 5. Yes, Elmer?
Wait, I think the length is 30.
Huh?
I think the length is 30.
Oh, you're right. The width is 4 times the length. My bad. Let me undo that, actually. Okay. Let's write again here. So if it's 30 to 300, and that reduces from 1 to 10. Thank you, Elmer, for pointing that out. Okay. And then what's the ratio of width to area? So it says area now. Can someone tell me that? Yes, Javon? 1 to 30. How'd you figure that out?
I did 120 to 36, and I divided both of them by 120.
Okay, so you did, we had to actually multiply 30 by 120. Did you do that for area? And what did you get? How much?
3,600.
3,600. And then width to area. So width was 120, so you did 120 to 3,600, and you got 1 to 30. Excellent. I like that. Any questions? Cool. Flip over to the next page, page 4. We're getting into some of the hard stuff now. Okay? Here what you have is you have some tables here and some questions. You have some tables and some questions. I'm going to give you guys, I want everyone in partners, let's work on just answer as much as you can with number 13, okay? So I'm going to give you guys about 4 minutes to try to answer as much as you can for number 13. Go. Take a look at this chart a little bit more closely here. So we have right now, Kenneth Kenneth is really interested in trees, let's say. Okay, and he's comparing the white oak and the coast redwood. The white oak is 119, right here, we can look at the chart. It's 119 feet in diameter. And then the coast redwood is 80 feet in diameter. So we're just actually looking at these two. Oh, sorry. We're just looking at these two numbers right here. And it says, Kenneth thinks it's a ratio of about 3 to 2. What does the word about mean? What does the word about mean? I haven't heard from for a while. Siani, okay. What does about mean?
About me.
Who can help her out? Kyla?
Estimate.
It means you need to estimate. What is 119 close to, Vidad? 120. So we're going to actually be comparing 120 to 80. Is this about, then, 3 to 2? Is this in the right order? Yeah, so the actual answer for Kenneth, this first one is yes, it is about 3 to 2. You'll have to learn how to do these problems. These problems like this might show up on your test at the end of this unit, okay? So you need to be able to read a chart and answer some questions, okay? But remember, even though you see all of these numbers in this chart here, it's actually not that bad. You just got to break it down a little bit, read the question, okay? Questions? Okay, let's move.